Welcome back. And so we just discussed all those different statistical tests, right? So that's a piece of that third step of the scientific method as viewed from a statistical lens, where we summarize results. Well, I mean, we actually need to summarize the results still because we've only started to do the analysis when we stated the test. Okay. So in general, when we include a summary, we should include the value of the statistic that's related to the parameter that we're studying. So if we're looking at a mean, report the sample mean. And then if we're doing a statistical test, which in this course we are, we'd want to report the p-value. Okay, but what is a p-value? Okay, that's a very tricky concept. So here's the formal definition. Okay, it says a p-value is the chance that or chance assuming the null hypothesis is true. Okay, so we have to think under the null hypothesis what happens. Okay, that the test statistic that we calculate, so the sample mean, for instance, could have a value as extreme or more extreme than what we got. Okay, so in this diagram, let's say that we got, if we're looking at, average height, and we're looking at a mean. So I think that the average for all humans is like 5'6" I believe. Don't quote me on that, but let's say I got a sample that had a mean of 6'2". Okay, and then I'm wondering, okay, well, to calculate the p-value, what I would need to do is look at anything that is more extreme in the direction of the extreme, actually, that compared to what I got. Okay, so the extreme would be anything you can see from this curve that the more likely observations are in the middle, the less likely and the more extreme results would appear off on the ends. So the p-value I would need to calculate, and we'll have software do this for us, but we would calculate everything that is from this point and towards a tail. Okay, and again, don't worry about doing this. We'll have Excel do this for us. But the idea with the p-value is that it effectively shows us how much support we have for our hypothesis. If we get a high p-value, then there's not a lot of support, because again, that's saying that it's likely to happen under the null hypothesis. So it doesn't seem to, it doesn't show enough support that it might differ from the null hypothesis. Whereas if we get a low p-value, that's going to show more support for the alternative hypothesis, because it's saying that it's unlikely to be true if we have the null hypothesis. Okay, so really what we want to do is look for low p-values. And so that's kind of where we're going to go with this. We haven't defined what low and high mean. We'll get there in the next video. But we would need to, as a part of summarizing our results, include this p-value if we do a statistical test. Okay, so I'll let you define the p-value in your own words. Okay, but the main thing I want to drive home before we get to the next video, and I'll mention this there, is that when we do calculations in statistics, we don't, the calculations don't prove or confirm or allow us to accept a hypothesis true. All we can say is that it shows support. Okay, so that's why I was very intentional at including this language of little support or more support, because again, we could get a different sample and get a different p-value, and that would cause us to do something different. Okay, so we just show support. That's all we do in statistics. Okay, and also the p-value doesn't tell us anything about the null hypothesis. It just tells us how likely our sample is to be representative of the null hypothesis. And similarly, and so all I can do is say, okay, well, we got the sample. It is likely or unlikely given the null hypothesis, and so then that allows us to say something about the alternative hypothesis. All right, so p-value, very tricky concept, but the idea is that what it does is it shows us if once we get a test statistic or some sort of statistic, how or how likely it is that we could have gotten that value or something as extreme or more extreme. Again, the extreme being something that's kind of out out on the extremities of the graph or the distribution that we're working with.